Alright, in this lecture, we'll talk about a big topic, fast Fourier transform, and specifically, in this particular chapter, we will talk about the theoretical development of FFT, fast Fourier transform, corresponding to the case where the number of sample data point, capital N, is equal to the product of three or more integer number. So for example, N is equal to R1 times R2 times R3, where each of the integer R1, R2, R3, they're all integer. And this formula can be generalized to R1 times R2 times R3 times R4 or anything. Okay, in this lecture number 21, if you remember several lectures ago when we talked about the so-called informal development of fast Fourier transform, at that time we say we have to restrict ourselves to the case where capital N has to be expressed in terms of 2 raised to a certain integer power r. So for example, at that time we consider r is equal to 3. That means the capital N is equal to 2 to the power 3, which is 8. That is what we have done long time ago. And then the previous two lectures consider the situation where capital N is not expressed in terms of 2 to the power r. Instead, it expressed in terms of 2 integer r1 times r2. Well, in lecture number 19, we consider the situation where r1 is equal to 4 and r2 is equal to 4. And then for lecture number 20, we consider the situation where r1 equal to 4 and r2 is equal to 2. But in both cases, you can see capital N is equal to the product of two integer, r1 times r2. So now we want to generalize the concept a little bit more. Now we say, how about the capital N is equal to the product of three integer, r1 times r2 times r3. Okay, where each of the integer r1, r2, r3, each one of them could be any integer, doesn't matter, could be any integer. But we particularly interest for the situation where, let's say, r1 equal to 2, r2 equal to 2, and r3 is also equal to 2. So that means we are talking about the number of sample data point, capital N, is also equal to 8. But that comes from the product of r1 times r2 times r3. It is not going in the form coming from the like 2 to the power 3. We will see by the end of this chapter that the formula that we developed for the computation of the unknown vector C theta based on the triple product integer will be identical to the case that we have done before for the situation expressed in terms of 2 raised to the integer power r. As a matter of fact, in this chapter we can generalize even more, because as you can see from equation 70, the number of sample data point can be expressed as the product of not only three integer r1 times r2 times r3, but it could be expressed in terms of a product of m integer r1 times r2 times r3 times r4 all the way up to rm. Oh, by the way, there's a typing error here. This should be r1 times R2 time R3 time R4 blah 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 time Rm is indicated in equation 70. Okay, now let's say the capital N, the number of sample data point N, can be expressed as a product of R1 time R2 time R3 time R4 blah 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 all the way to Rm. That means we say capital N can be expressed as the product of M integer. Well, in that case then the small index n supposed to go from 0, 1, 2, blah 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 up to capital N minus 1. However, as you have already seen from the previous two lectures, the small index m that you got in here can be expressed in terms of n0, n1, n2, n3, blah 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 blah, nm minus 2 up to nm minus 1 according to the equation 71 that I show you over there. In case you forgot, if you remember, in the situation where you have expressed the capital N is the product of only R1 times R2, then the formula shown in equation 71 will be involve only a few terms instead of so many terms as indicated in equation 71. Similarly, the small index k in this case should also go from 0, 1, 2 up to capital N minus 1. Again, this small index k can be expressed in terms of the index k0, k1, k2, blah 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 blah, km minus 2 and km minus 1 as shown in equation 72. Now, in equation 71 and equation 72, keep in mind that it also involves with those parameters like R1, R2 up to Rm minus 1 or R2, R3 up to Rm, depending on you make use of equation 71 or 72. So, what is the value of R1, R2 up to Rm? What are those values? Well, in general, those are given. You see? So, for example, R1, R2, R3, R4, up to Rm, they are given because you know the value of capital N, it comes from those R. Now, the question now becomes, what is the range of value that you can have for N0, N1, N2, Nm minus 2, Nm minus 1? Or similarly, what is the range of value you can have for K0, K1, K2, blah blah blah, Km minus 2 and Km minus 1? So to answer for those questions, we say equation 73 will give you the value for those number Ni minus 1. So all the value for N0, N1, N2, blah blah blah, Nm minus 2, Nm minus 1, they are all given by equation 73. And please be careful, in equation 73, I is between 1 and m. Similarly, the range of value for K0, K1, K2, blah 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 blah, Km minus 2, km minus 1, those value range are given as indicated in equation 74, as you can see. And in that equation 74, the value of I is between 0 to m minus 1. Actually, you can see equation 71, 72, equation 73, 74, they are very similar to the previous case that we discussed, where n is equal to the product of two integers, r1 equal to r1 times r2. And in the previous two chapters, we consider r1 equal to 4, r2 equal to 4, and then for the other chapter, we consider r1 equal to 4 and r2 equal to 2. But for those two chapters, the formula we have for n, k are very, very similar to equation 71, 72, except they are shorter. And similarly, for those two chapters corresponding to the capital N equal to the product of R1 times R2, we have a similar equation for equation 73 and 74, as in this more general case. So those are the definitions we have for the small index n, the small index k, as I show you in equation 71, 72, and the range of value that you have for small n with the subscript I minus 1 and small k with the subscript I, as indicated in equation 73 and 74. Well, instead of trying to generalize it for the situation where capital N equal to a product of m integer, r1 times r2 times r3 times r4 all the way up to rm, let us try to simplify a little bit by initially just focus on the product of r1 times r2 times r3. Okay, so right now